This work is in collaboration of Professor Brighente, Professor Conti, and Edoardo from the University of Padova. So this is a systematic review of remote keyless entries for vehicles, and the attack techniques developed over the years, and some defenses and countermeasures that could help to prevent these problems. And also we will look how to what we can do for the future. So the outline, brief introduction about the system, the research question and methodology. And after that, I will just introduce RKE and PKES. I don't know if probably everyone in here just already knows about them and the technologies for these systems. And then the attacks, defenses, and research question answer. So the first example, so actually the first remote keyless entry is dated back to '82, and it was introduced by Renault, and it was a really simple infrared controller. So just pointing to the car, pressing the key, and it will open. Like, it's just like the old TV. So if you just point to somewhere else, it will not work. After that, they started to integrate also different anti-theft systems because they noticed, okay, this is quite vulnerable. For example, the immobilizer, so the car will not start if there's not the key present inside the vehicle or you don't turn it on, obviously. But nowadays it's much more complex, so also there's the involvement of different channels, physical channels, for example, Bluetooth, or also now you can use your smartphone to unlock cars, so more vulnerabilities upcoming. And the problem also is that usually they are closed source solutions, so everyone needs to reverse engineer them before. And that this leads to exploitation and car theft. So why we did this? Actually, we had some research questions coming up. So we wanted to understand if there is an increased security about these systems. The second one is how these attacks evolves during the years and during like the presentation of new technologies on this. And then if actually like the defense strategies are useful, there are a lot of defenses especially in literature more than in the industry side. And so why they are not used and where they actually use that. And at the end, the last question is, what is needed to develop a truly secure remote keyless entry? And we try to answer it because it's not so easy. So the methodology was actually checking everything in the main, in the 4 top conferences about cybersecurity. You already know them. And also in the industry hacking side. So the main ones are DEF CON, Black Hat, but also car hacking villages. Car hacking village, VehicleSec. And we started dating back from 2005. That is actually where the first paper about this appeared. So remote keyless entry. I think you already know them. So the easiest way was just getting a key that it doesn't need, like you just need to press a button and the car will open. And now we have also the passive keyless entry. So you don't need even to press a button. You just need to go close to the car and it will open automatically. And at the beginning was just a single fixed code. So anyone getting the code will open the car also later on. So this is actually the schematic for the new let's say new rolling codes. So when you press a button, there is actually a counter both in the car and in the keyless entry system, in the key fob. And the key fob will send this code. The car will check and verify if it is the expected code, and then it will update it if it is okay. And the key fob will update also to the new code to send at the next interaction. So this is actually obviously more convenient. You don't need to open your bag and find the keys. You don't need to do anything. Also, some cars, when you go very close, you can also like use your feet and open the door in the back. But also means more attack surface. So about the technologies, we started with the like whatever we found. So the first one was, let's say, is just cryptographic things on how to generate the codes. So for example, we had DST40, the keylock, ITAC2, that is probably the most famous about cryptographic stuff. And then some others like DST80 that came up after the vulnerabilities of DST40. So, and in the table you can see, and obviously you can find it in the paper, where these cryptographic functions are inside the system. So for example, only in the remote keyless entries, or if they are in the immobilizer. While later on, they started doing everything with NFC and Bluetooth. So this is on for the passive keyless entry. So the communication channel will be established automatically with just going close to the car. And more recently, we also have ultra-wideband channel and whatever is based on internet access, let's say, so API-based and third-party application to manage, to open the car from, I don't know, you're in the office and you want to open the car, I don't know why, or whatever, you can just use your phone. So we checked every attack, as I mentioned before, and these are all of them, and we categorized them based on the, let's say, the class of what they are targeting and the, like the means to do them. So you can see the majority of them are cryptographic attacks. So they essentially break the cryptographic systems in these remote keyless entries. So at the beginning was much easier, obviously. Now is more secure, luckily. And they are based on exhaustive search. At the beginning it worked. Now is much easier, is much harder. And actually you cannot do it anymore. We have cryptographic systems that are secure against brute forcing. But they could have vulnerabilities on guessing and determine if you're getting like correct guessing for the keys. And some other attacks always based on cryptographic. I cannot stay here all the time, like all the time on enumerating them. But now there is like the few last attacks in the years. The most recent for cryptographic systems were power analysis. So they also adapted to extracting the key of a key fob and checking also if all the key fobs share the same keys, and actually was the case. So one public key, one private, but common key for all the key fob from the same companies, for example. So you just extract one, you can open every car. And then we had also in 2011, if I remember well, like probably one of the most famous attacks, that is the relay attack, that is still available, like still, let's say, useful for thieves right now. And also the jamming and replay attack from 2015, from I think was the presentation made by Sam at DEF CON. So, and all the attacks that are coming up from the original one. So that's why we have more attacks on jamming and replay attack in this case. And then all the problems that came up using Bluetooth and NFC and the web services that are probably the most important ones right now, because they are opened the attack surface to whatever is based on internet. So every attack that we have on web servers, now they are even on cars, let's say. So just to present some of them, this is the RollJam attack. So probably also you know about this, but is essentially jamming the signal from the key fob to the car while registering it. So not so easy, but feasible. The victim will maybe try to open it again later on for the vehicle, and you still jam it. So the first, let's say, with the counter not updating the car, the first signal will be still valid. So you can use that, replay it, and open the car. While the relay attack is just getting like an extension of the physical channel between the key fob and the car. So the car will be tricked to think that the key fob is actually close to the car itself. And for this, let's see that we can see that they try to present different defenses based on distance bounding techniques, for example, and also some other based on the timestamp, all the authentication against, for example, also the path-based, so physical unclonable functions. And so we have actually different defenses that maybe we can use, like at least the paper said that are possible to integrate on real devices. But coming to the answer of the questions, like, so the first one was, did the evolution of RKE and PKES technologies increase their security? We can say yes, they are generally more secure, but the problem is the cryptography is much better, obviously, but the exposition to the internet and, for example, with API and with servers are making them more vulnerable on that side, so not on the physical channel between the car and the key fob, but on the internet itself. And also, let's say that the relay attack, as we can see in the second answer, so how did attack strategies evolve in time? They didn't evolve so much, essentially, because the relay attack is still like easy to use and is diffused. Like if you check any news on papers and on internet about car thieves, they are still using this attack because the physical channel is the problem. So it's not so easy to integrate actual defenses on them. And maybe, I don't know, let's see the answer for the fourth question later, but we need to put these defenses on work. So about the defense strategies that are deployable and effective, yes, but the studies are usually not on real-world systems. So let's say they are feasible on a theoretical aspect, but we need a little bit more research on this side, in my opinion. And also the problem is if vendors are actually using them, because for now we can still have attacks on the real, like on the wild about this. So it means there's no actual defense on the devices. And so coming to maybe the most important part is, what do we need to develop an effective and secure remote entry system? So first of all, this was more on our side. So the security by obscurity obviously is not working. So we actually need vendors that are available to test and maybe open with an open source system and checking for vulnerabilities directly from the community. Maybe this will probably get better defenses at the end, because they can find vulnerabilities before they are on the wild already. So faster communication with the security research community will probably be the best thing. And also, actually, we can consider some takeaways was considering the guidelines for secure RKE systems, because they exist, but probably they are not totally followed. Because still, if I remember well, they are guidelines and it's not still mandatory. Maybe it's from this year, not really sure. I should check. And so for the academic research, maybe we should check only, we should go to the side of new technologies, and maybe see what is actually going on the web application and API testing techniques that are probably the most important parts right now. So, okay, to conclude, we presented a systematic review of the remote keyless entries and passive keyless entry systems, and all the attacks that we identified as actually working and exploited in the real world, and the defense that we can find against them on a research side, are luckily not completely developed on real systems. And then we answered the fourth research question that I just presented, and foster a new future, present new future research directions for the academic part. So thank you for the attention. If you have any questions.